Now in this video we'll talk about source specific multicast. Now before we go ahead with the source specific multicast, let us quickly revise the classic multicast which we have used in our previous sections by using IGMP version 2 and the PIM parts mode or dense mode implementations. Now we call this kind the implementations whatever we did as any source multicast. Now any source multicast means we are expecting a receive to receive a traffic for so and so group, let's say here 224.5.5.5, and the source can be anything. Now the receiver who wants to receive the multicast traffic do not know where is the exact source address for that particular group address. So it's going to send some IGMP request or IGMP report message to the router. The first hop router is going to send that information to the RP. It's going to send some PIM join messages, and then the source who wants to send the multicast traffic has to register themselves with some PIM register messages. Now once the RP learns about the source and the receivers, it's going to provide the information, and from the receiver to the source it's going to build the shortest path entry. Now this is how the typical parts mode is going to work with the help of RP. Now if you're using dense mode, there's no RP configuration, but the information is flooded throughout the network and prone. Now probably dense mode is something not really scalable, we discussed that, but in case of sparse mode, in order to learn about the source and the receiver, there must be some router called rendezvous point has to be configured. Now the sparse mode uses RP, and the receivers do not know about the source, and the sender and the receivers should know each other via RP. So they know about each other via RP, and the source is going to use some S-G entries, PIM register messages, and the first hop router is going to send some *G entries, and the receiver knows about the source via RP. Now this typical any source multicast is something we are expecting the multicast traffic from any source. But the major drawback with this any source multicast is the receiver do not know about the source initially unless they learn from RP. Because the receiver here, let's say on the router 4, he don't know who is the source, so it's going to build some *G entries towards the RP, and the RP is going to provide the information about the source, then it's going to build the shortest path. So if the RP fails, it's going to be a single point of failure, and there is no new tree builds. Like if you have a new source and sending a traffic for the new group, probably it's not going to build any more trees. So the RP is something mandatory to have if you're using PIM sparse mode. Now to overcome this, we need to there is something called extension to that. We can, instead of using an RP, we can tell the receiver who wants to receive the multicast traffic, if he knows about the source directly, it will avoid the RP in between, because here the RP is going to provide information about the source and the receiver. And we want to ensure that the receiver who wants to receive the multicast traffic for that particular source, he knows about the source, and he can send the join messages directly to the source instead of sending them to the RP. So that can be done. So we need to have some solution for that, and the solution is source specific multicast. Now in the source specific multicast, the receiver knows about the source and is going to send some join messages direct to the source instead of sending it to the RP. Now in case of RP scenario, the receiver do not know about the source, so it's going to build some *G entries, sending some PIM join messages to the RP. But in case of SSM, we are going to send the join messages direct to the source, because we know exactly where the source is. Now to make that possible, we need to use something called SSM. That is what we call as source specific multicast, where we are receiving the multicast traffic from specific source rather than going unknown source. Probably we are going to learn about the source with the group address. Now to use this SSM application, we need to use a specific range dedicated for that. So let's say if I have a receiver and I want my receiver to send the join message direct to the source based on the S-G entries. Now we are going to use some special multicast address, that is 232.range. Anything starting with 232 is the default range for source specific multicast. And the next requirement is the receiver should know the application source before it sends the membership. Now here I got a receiver here, and this receiver, let me take receiver here. Now this receiver is going to send the join message direct to the source. based on the source, which means the receiver should know. In fact, receiver means the first hop router. So it's going to send IGMP join messages to the router, and the router is going to send back directly to the particular source router, and he should know that particular source where he is exactly. Okay, so which means that particular router should be capable of knowing the exact source for that particular multicast group, and that can be done by using some IGMP version 3 protocol. Now to make this available, now if you want to use SSM, we are going to use something called IGMP version 3, which is going to help that particular router to learn about the source and build some S, G entries. And there is one more thing, is the application whatever we are using on the receiver side, probably the router on that interface is going to run version 3 IGMP protocol, and the application should already aware of the source so that it can send some join message direct to the source. Now the major advantage we get is it removes the need for the RP. So here the join messages are not going to the RP, instead it is going to direct to the source routers. The last hop router is going to use S, G join messages towards the source. That's what we discussed. The last router send S, G join messages, and the SSM is going to build only S, G entries. There is no more star, G entries. So because there is no need for the RP here. Now the source specific multicast is going to be much more easier to configure, as there is no need for the RP, and just we need to verify the shortest path to the source. Just we need to ensure that the particular receiver knows about the source and it uses automatically the shortest path to the source. So no shade tree is required, no RP is required, and clients just need to know the source. Now the major thing is, let me just conclude this. SSM is going to use something called IGMP version 3, which allows the receivers to specify the sources from where they want the multicast traffic. Like take an example here, this is the source address is 10.1.1.1, and it's sending the multicast traffic for 232.5.5.5, and this router, now the receiver knows exactly how to reach that particular source address, and it's going to build the shortest path to that particular source to get the multicast traffic directly without a need for the RP.